This is TWiT.
You know, we mentioned earlier Bob is not here tonight, but don't fret, we have some pine board action for you here nevertheless. Well, I don't actually have a pine board, but I've got some splaining to do. Because I told you last week, we mentioned that we'll be talking about the transmitter there, and I said I need to talk a little bit about a Pentode tube, and let's explain how the Pentode works before we start explaining the transmitter. So that's what I'm going to do tonight. I've got some drawings here, and I've got some colored markers, so I think we're all set to go. You know, we've talked about the triode before. If you want to learn the basics of how a vacuum tube works, go back and watch Ham Nation episode 303 when I talked about a triode and did a basic but thorough explanation of how a tube works. And we'll just briefly touch on that here first. This is a triode. You can see there, well, we call it a triode because there's basically three elements in it. There's a cathode right there. There's a control grid, and there's a plate. Now, there's also a filament heating that cathode in there. We're not counting that as one of the elements when we state this as a triode. In some cases, you know, there may not be a cathode. The filament itself might be the cathode. So let's just begin here. We put some voltage in here at the bottom to the filaments. We heat that filament up. We have the cathode here connected to ground or nearly to ground. There might be a little resistance or and parallel capacitance in it there, but the cathode is generally sitting near ground. Up here on the plate at the top, we're putting in a positive voltage. We call it plate voltage. That's a pretty high voltage coming in there. Well, in the case of the pine board transmitter, it's I believe between 100 and 200 volts currently in the current iteration of that design. So we're sitting up here, we've got a high positive voltage on the plate. We're heating up this cathode down here. What's going to happen, once that piece of metal gets hot enough right there, it's going to start boiling electrons off of this cathode here. Well, those electrons are going to want to leave that and go somewhere. And they look and they see this plate up here at the top, and that's a positive voltage where these electrons are negative. They're going to start heading in that direction. And they're going to jump off that cathode as they're boiled off and head toward the plate because opposites attract. Well, what's going to happen there is the thing's just going to run wide open. We've got a control grid here between the two, though. And on this grid, we'll put a smaller voltage. It'll be a negative voltage. So we've got a negative voltage going in here. What that's going to do is when the electrons start boiling off, they're going to see that negative voltage on that grid, and that's going to repel them, and they're not going to go through quite so fast headed up toward the plate there or with quite as much strength. Now, we'll also, here on the input, we'll put a signal in. Let's say we put in a little sine wave there. Now, that's going to cause the grid to swing positive and negative. And that's going to sort of choke off the electron flow or act as a valve to control the electron. So when it swings high and swings low, the electron flow is turned on and off. It's not digital. It's, an analog device. So it's going to be directly proportional to whatever our input signal is. So that basically is an amplifier because we're sending electrons up here to the plate, and we're controlling the flow of those electrons with the signal that we're sending into it. So that's how a triode works. And it's the oldest tube out there. So it's very much used. That's Well, we talked about it earlier when we were talking about the preamp. Now let's step it up a notch. Let's put another grid in there. Now this is a tetrode. We've got basically the same thing here. We've got the filaments, we got the cathode, we've got the plate, we've got this control grid here that we put in the bias and our input signal, but we've introduced another grid here. This is the screen grid. Now, we'll put a little voltage on this screen grid right here, a positive voltage, as a matter of fact. And what that's going to do is, as the electrons start boiling off of the cathode there, this green grid here is a little bit closer to the cathode than the plate is to the cathode. And it's got a fairly high voltage on it too. It's generally a little less voltage than the plate voltage, but still, usually a fairly high voltage on it. So this kind of gets those electrons flowing with more gusto. When they start boiling off of there, they see that positive voltage on that screen grid and they're attracted to it, at a little bit more strength. Once they get there, they look up here and they say, wait a minute, there's a higher voltage up here on this plate. So they just go on past the screen and hit the plate. Okay, so we get a little more gain out of that tube by having the screen in there, because it just helps improve the electron flow. Now, there's a little flaw with the tetrode here, and what that is, once we've got the kinetic energy of those electrons being boiled off that cathode, headed toward the plate, they're going to strike it so hard that some of them are going to bounce back down. They're not going to go all the way on out the circuit here. They're going to be reflected back toward the screen. And that's going to cause a little bit of screen current to flow as well. So we're not getting the usage of all these electrons coming off of here. Some of them are being wasted. They're going back toward the screen. Well, they got to thinking about it, and I believe it was Muller came up with another tube design, the Pentode. Now, this is the tube that's being used in the pine board transmitter. It's basically the same thing we got before. We have the filament that's heating up a cathode. We've got the plate up here at the top. We've got the control grid. We've got the screen grid that we're putting a positive voltage on too. And we've got one more grid in here. This grid is called the suppressor grid. And if you look here, it's not tied to positive like the screen and the plate. In this particular case, it's tied to ground, or it could be, it'll be a lower voltage. It won't be anywhere near the screen voltage or the plate voltage. It's going to be negative compared to those. In this case, ground is plenty negative compared to the high voltages there. So what's going to happen now is those electrons start leaving down here on the cathode, and they're headed up toward the plate. They're going to hit that plate real hard because, they've got the little extra attraction there that the screen grid got them started heading that direction, and they see the plate up there and the high voltage on it. They rush right on past that screen, hit the plate. Now, instead of some of those bouncing back like they did before, when they try to bounce back, they look here and they see this suppressor grid. And it's got a negative potential. So these electrons being negatively charged, they're not going to want to leave that plate and flow toward another negative because, opposites attract. So the same sign would repel. So with this being negative here on the suppressor grid, those electrons aren't going to be knocked off and reflected back down into the tube. They're going to be more focused right on up into the plate there, which means we're going to get a little more gain out of this tube. Also, there's a tendency when you've got the electrons reflecting back down in the tube, with it being pretty high gain with that screen voltage, the tube can go into oscillation pretty easy. By putting the suppressor grid in here and having it grounded or, at a negative voltage, it changes the interelectrode capacitances of that tube, and it's not quite as likely to oscillate. So that's another advantage of it. There are numerous other benefits from it, and they get a little more complex. I just wanted to show you basically what each of these grids is and, what its function is. So same old tube we had before. Put an input signal in here. It's gating on and off. The electrons boiling off that cathode at the rate of the input signal. Screen voltage here on the screen grid kind of gives them a little kick in the seat of the pants as they're headed toward the plates. They're going so hard at this point with so much kinetic energy, they jump right past the suppressor grid. But any of them that would be potentially reflected back are repelled by the suppressor grid. And of course, we've got our positive voltage we put on the plate here. Our signal comes out here. We've got to have some way to separate our signal that we're putting in from that high plate voltage there. The way that typically would be done, and it's a little more involved in this, but in the most basic sense, we would just have a capacitor coming off of that plate and would get our signal on out here. So we don't have that high plate voltage coming to the output where we're trying to connect our next stage to. So there you go. That is basically how a Pentode works, and that's a tube that's going to be used in the Pine Board project transmitter. And I believe Bob will be back with us next week. We'll be talking more about that. It's fairly interesting. We've already covered the preamp and how all of that worked. This is RF. This is a little bit different, so stay tuned for that.